Okay, lads, I just want to look at question 10 of your mock paper. I'm going to go through the whole lot from beginning to end. For a new species to be formed, what condition must be met by all the offspring? Okay, so if you think about your definition of a species, it is individuals that can interbreed and produce fertile offspring. So the condition that must be met there is fertile offspring. So that's the answer there for the first part, fertile offspring. Part 2. Variations occur between all members of a species. Give one example of variation in humans. And you can just talk about eye color, for example, is a variation, an inherited variation. Okay, and part 3 then says name one cause of this variation. So a cause of this variation there is definitely sexual reproduction. Okay, so sexual reproduction is a cause of that, because sexual reproduction, there are, and you can add to that, you can say there are different alleles, okay, different alleles for the same gene, okay, and you can say that only certain alleles are passed on, okay, only certain alleles are passed on. Now, I don't think on this mock paper they actually require that much, but it's good to kind of elaborate as well and just explain what you're talking about there in terms of sexual reproduction as being an answer. Okay, now hopefully now you can, I don't know, can you have your paper in front of you? I'm out of ink down here, so I can't have the paper in front of me, okay? So I'm just going to call out the questions and I'm going to do the solutions then in front of me, okay? I hope that's okay. So in rabbits, black-eyed B is dominant to red-eyed B, and long ears L are dominant to short ears L. Now, I always like to write all this information down myself, nice and neatly. Okay, so we have black. So a black-eyed rabbit, okay, is going to be given big B because it is a dominant trait. Red is going to be given small b because that is a recessive color, okay, for eyes. We have long, okay, long. Now, very important to dramatize your L here, because it'll be very easy to mix up big L or capital L with a small l for short. So short here is going to be given a small l, and we're going to have a little loop there just to emphasize it as well, so we make no mistakes, okay. We're told here, part 1, okay, we're told a black-eyed rabbit with long ears was crossed with a red-eyed rabbit with short ears. The offspring of this cross included some rabbits with black eyes and short ears, while others had red eyes and long ears. Assuming the genes are not linked, that's important, using the symbols given above, write out the genotype of the black-eyed, long-eared parent. Okay, so the approach for this one. Well, the first thing anyway is write down what you know. We have parent 1 and we have parent 2. Okay, parent 2 should be the one that you focus on straight away anyway. So we're told here a red-eyed rabbit with short ears, and there should be no doubt about what that one is, because if you're red-eyed, it means you have to have both alleles for red. So small b, small b. And if you have short ears, that's a recessive characteristic, you have to have both alleles for red. So again, I'm going to emphasize those. This is the parent 2. We have small b, small b, small l, small l. Parent 1, however, could be a few different options if we just ignore the paragraph a second. Well, if you think about it, you could have a black-eyed parent who has both dominant alleles, and you could have both long alleles. You could have a parent as well which has big B, small b, big L, small l, because both of these are heterozygous. You could have a situation where parent 1 is, let's see, you could have big B, big L, small l. Or you could have big B, small b, and you could have big L, okay? In other words, you have 2 dominant black, 2 dominant long, and so we have 4 options really. to choose from. And how do we narrow it down to the actual parent? Well, read the paragraph again. A black-eyed rabbit with long ears was crossed with a red-eyed rabbit with short ears. There's no clue in the first sentence. The offspring of this cross included some rabbits with black eyes and short ears, while others had red eyes and long ears. If you think about that for a second, is there a clue there? There is. So offspring must have red eyes and long ears. So let's look at this. If parent 1 was big B, big L, and it crossed with this parent here, could you have offspring which have red eyes and long ears? The answer is no, because if you think about it, they're all going to be heterozygous. They won't have red eyes and long ears. It's not possible. If you look at this option here, if you have big B, and you cross it with small b, again, they're all going to have black eyes, the offspring, so it can't be that option either. And if you look at this option here, big B, big L, again, they'll all have long ears. So therefore, there's no possibility of having short ears. So therefore, the answer is this one here. So let's say, are we actually answering the question? The final sentence says, assuming the genes are not linked and using the symbols given above, write out the genotype of the black-eyed, long-eared parent. So the genotype answer for this one is big B, big L, small l. Okay, and that's the answer there for that one. That leads us on then to part 2. For part 2, we're told what percentage of the offspring have genotypes that differ from the parents. Write out the genotype of these rabbits. Now, again, for this one, you have to do a genotype cross. It's not telling you to do a genotype cross, but you just need to know that you need to do it. Okay, how can we find out what the offspring's genotype is and answer this question? Well, what you can do there is do your Punnett square cross. So I have big B, big L, small l, times small b, small l. Okay, this leads us on to what we just did previously, which is work out possible gametes. Okay, so what are the possible combinations here in the sperm cell and the egg cell that's going to be passed on? Big B could go with big L, so big B, big L. Big B could go with small l. So again, dramatize it, make it really small. We have small b could go with big L. Small b could go with small l. Okay, so that's for parent 1. Parent 2 is a bit more straightforward. Small b, small l. So small b, small l. And again, you could have small b, small l. It's going to continue like that. Small b, small l, and small b, small l. Because big, small go the first one here with L, big or small b with small l, small b with small l. So you get 4 options there. In actual fact, we just pick out one of them, and that will make it easier for ourselves because you'll see the combinations then. Okay, so Punnett square cross. Remember, you put down all your possible gametes down the side. Big B, big L. Big B, small l. We've small b, big L, small b, small l. And again, small b, small l. We work out our genotype cross. So we have big B goes with small b, big L, small l. We have again big B, small L, small l. Small b, big L, small l. And small b, small l, small l. So let's see what we're being asked to do in this question. It says, for this question, what percentage of the offspring have genotypes that differ from their parents? Okay, to work that out, you need to look at the parents. Big B, big L, small l. Big B, big L, small l. So that's the same. The second parent is small b, small l. So that's the same. So therefore, if you look here, these are different and these are different. I want you to study those in your own time. You can pause the video and look at those. So therefore the answer for part 2 is 50% different. Okay, that is part 2. Part 3. If the above genes, so I'm just going to look at this one here, part 3, if the above genes were linked, explain how the percentage you have indicated in your answer part 2 would change. Okay, so the problem with this question is we have to make assumptions. Okay, so it says again, if the above genes were linked, explain how the percentage you have indicated in your answer to part 2 would change. Our assumptions here would be that black goes with long and red goes with short. So therefore, if the above genes were linked, explain how your percentage in your answer would differ for part 2. So therefore, now we would have something like this. Big B, big L, so big B, big L, small b, small l. Okay, and we're crossing that by small b, small l, small b, small l. And when you do your possible gametes, you will have big B, big L, or small b, small l. For the second one, parent, you're going to have small b, small l, or actually it's exactly the same, small b, small l. Okay, when you look at the crosses, so genetic cross, and you're looking at the offspring genotype. So for this one, big B, big L could go with small b, small l. Big B, big L again could go with small b, small l. Small b, small l could go with small b, small l. And small b, small l again could go with small b, small l. So what have we learned from this? Well, again, 0% different. Now the problem in the terms of an assumption here for this one is that when I look at this one, here, sorry guys, the camera's not great. When I look at this one here, the assumption we made is that big B was linked to the long hair, and small b, which is red, is linked to short hair. Okay, that's the assumption. But really, if you go back to this question and just read it again, do I need to do all of that Punnett square cross just to answer the question? It says, if the above genes were linked, explain how your percentage you've indicated in your answer would change. You could actually just mention here that due to independent assortment leads to greater variation of genes, and because there is linkage, there is less variation. All they were looking for actually was, for this one, less variation, and they accepted any answer less than 50%. Okay, if you mentioned 0% there, that's how you got your marks. So that is up as far as part 3. I'm now going to move on, and we're going to look at the final question here, okay, which is again part 4. Okay, so let's see, part 4. Now, for part 4, we're told that we have got some of the black-eyed, short-eared rabbits are then crossed with the red-eyed, long-eared rabbits. Again, assuming the genes are not linked, answer a few of these questions. So, this paragraph is packed with information. Let's just pick out what we need first of all. We're told black-eyed, short-eared rabbits from the previous part. Okay, so black-eyed, short-eared rabbits, the black-eyed ones were, if we look at it, our Punnett square here in front of us, this is black, short. So this is black, short. This one is red, long. Okay, so the first question we're told, our first one here, we're told that it's a black long. No, black short rather. So some of the black-eyed short-eared rabbits. So black short, big B, small b, and we have small l, small l. That's going to be parent 1. And parent 2 is going to be, we're told that it is the red-eyed, long-eared rabbit. Red-eyed, long-eared rabbit. Red, long. So therefore it's going to be small b, big L, small l. Okay, moving back to this sheet now. We have our information that we need, parent 1 and parent 2. So again, assuming the genes are not linked, so there's no linkage, we're ignoring part 3 now. Again, we're going back to part 2. What percentage of the offspring of the cross are homozygous for short ears? Now, the only way to answer this is to do a Punnett square cross. So this would be a seriously long question on your exam, but it's worth it, okay? You can pick up a lot of marks on this one. Possible gametes, again, is the first thing. So possible gametes. So let's look at it. Big B could go with small l. Big B could go with the other small l. Small b could go with small l, and small b could go with the other small l. That is the first set of gametes. Parent 2. Small b could go with big L. Small b could go with the other small l. We have small b, this one could go with big L, and small b could go with small l. Right, we have to do a Punnett square cross on this one. Now, be so careful when you're doing this because it's so easy to make mistakes. Dramatize your answers. Okay, so we have big B, small l, big B, small l, small b, small l, small b, small l, small b, big L, small b, small l, small b, big L, and small b, small l. You do your Punnett square cross on it. So big B goes with small b, big L goes with small l. We have big B, small L, small l. We have big B, small b, big L, small l. Big B, small L, small l. Again, big B, big L, small l. Big B, small L, small l, and continuing on. Okay. Next thing we need to do is we need to work out percentages. So what percentage of the offspring of this cross are homozygous for short ears? Best thing you can do, underline. Okay, homozygous for short ears. So homozygous for short ears would mean that you have got short ears, so therefore L, two small L's. Okay, homozygous for short ears. Right, so 1, 2, 3, 4. This is not because this is heterozygous. 1, 2, 3, 4. So therefore the answer for the first part 1 is 50% because we have half the number here have got short ears. Homozygous for that characteristic. Part 2. What percentage of the rabbits have black eyes and long ears? So black, long. So if you have black long, it could be big B, small b, L, and small l. It could be dominant alleles. Remember, big B, big L, big L. And there's a number of different combinations. Small b, you can have small b. No, you can't have, you can have. Okay, let's have a look at it and see instead of wasting time. Okay, black long. This one here, we're going to put a star on it if we believe it's black and long. So this one here is definitely black and it's long because it's heterozygous for both. This is the same. It is heterozygous for both. This one here, all of the ones I put a line under can't be because they're actually short. So we only look at the ones that I've highlighted here. We have another one, black, long, black, long. This one can't be because that is red, 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 red. So if you look at that, that's 4 out of 16. So 4 out of 16. Therefore, that is 25%. Part 3. Now, part 3, I was looking at this myself in my own time. It says, what percentage of the black-eyed, okay, we'll write it down. What percentage of the black-eyed offspring, okay, the black-eyed offspring are heterozygous for this trait? Okay, so for this trait. So what percentage of the black-eyed offspring are heterozygous for this trait? So if we look at the black-eyed offspring here, we can see here that we have 1, 2, 3, 4, 5, 6, 7, 8. And this question, I don't think is very clear. The answer for this one they're accepting is 50%. But what percentage of the black-eyed offspring are heterozygous for this trait? Heterozygous for being black-eyed? Well, heterozygous would be 1, 2, 3, 4, 5, 6, 7, 8. So therefore, of the black-eyed offspring, which are heterozygous for being black, I would say is 100%. But I understand why they're saying 50% because I think what they meant to say is what percentage of the black-eyed offspring are heterozygous for both traits. Okay, so I think there was a mistake on this one, this particular question, that they didn't finish off that question there, because if you're asking here what percentage of the black-eyed offspring are heterozygous for this trait meaning black eye, I would say 1, 2, 3, 4, 5, 6, 7, 8. They're all heterozygous for being black-eyed. But what they mean to say here is what percent of the black-eyed offspring are heterozygous for both traits. 1, 2, 3, 4, and that's why the answer on the marking scheme was 50% and not 100%. Okay, so never mind that, they won't make mistakes like that on the June exam. Part 5. Would you expect short ears to be an advantage or a disadvantage to rabbits? Any valid reason here. So you could say long ears are an advantage because that generally means you have better hearing. Okay, that was that question. I hope that made more sense for you. Have a go at the questions now, please. I've uploaded.